Dear students, in today's class we are going to discuss the numericals on radiation heat transfer. So let's begin with the first numerical. Just I am copying pasting the first numerical. Okay, probably it is visible to you. Now I am going to start interpreting the data given in the numerical. Now what is given here? A gray surface. Now what is meant by gray? Some mathematical data is hidden in the word gray. When the gray surface come into picture, that means Kirchhoff's law is followed. Alpha is equal to epsilon. Means Kirchhoff's law holds good for gray surface. So we are getting a mathematical data alpha is equal to epsilon. Now next, opaque surface. Now opaque surface also contains some mathematical data. What is that? Tau is equal to 0. But as you know that for any surface alpha plus rho plus tau is equal to 1. So that means alpha plus rho is equal to 1 for opaque surface as tau is equal to 0. Now it has absorptivity of 0.7. What is absorptivity? It is denoted by alpha. It is given as 0.7. It is maintained at 200 degrees Celsius. So that body is maintained at how much degree Celsius? 200 degrees Celsius. Let's convert it into Kelvin as the problem is of radiation. So I think it is becoming 473 Kelvin. Okay, by adding 273. It's very important in radiation chapter to convert temperatures in Kelvin before going to substitute. It receives an irradiation. Irradiation means what? It is denoted by capital G. 1000 watt per meter square. Surface area of the body is given as 0.2 meter square. Calculate. So what is asked to you? Required. Number 1, rate of heat absorption means QA. VA stands for absorbed. Rate of heat reflection QR. And third, radiosity of the surface, that is denoted by J. Okay. So QA, let's discuss about the unit. Q is asked means watt. Q is asked means watt. And J is asked, J means radiosity, that is in watt per meter square. So we need to get the answers in this unit. So let's start with the solution. Now, every body responds to incoming irradiation by 3 ways. Energy is absorbed, energy is transmitted through the body, and some energy is reflected back, QR. So what are the formulas of this? QA is equal to alpha GA, QR is equal to reflected means reflectivity is coming into picture, rho ZA, and transmittivity QT is nothing but tau is coming into picture, tau ZA. Now what is asked to you? It is asked to you to calculate heat absorbed. So we are going to use this formula. What is asked to you? QR, that is heat reflected. So first two formulas are only going to be used. So let's start. QA is equal to alpha GA. Now what is the value of alpha? Let's check in the data. Alpha is equal to 0.7. It is given here. 0.7. How much is the G? 1000. And what is the area given? 0.2. So the answer of QA is, I have already calculated it for you, 140 watt. This is answer number 1. You cross check it with your calculator. Now Q reflected is asked, that is rho ZA. What is the value of rho given? No, rho is not given. So you need to calculate it. How to calculate? For opaque surface, alpha plus rho is equal to 1 as tau is 0. So alpha plus rho is equal to 1. So what is rho? Rho is 1 minus alpha. What is alpha? 1 minus alpha is 0.7. So rho becomes 1.3. And therefore QR is equal to, rho value is 0.3, G value is 1000 and area value is 0.2. The answer of QR is something 60 watt after calculating on calculator, and this is your answer number 2. Highlight the answers. Okay, and finally they have asked, QA is over, QR is over. Now they have asked radiosity J. What is radiosity J? It is the summation of or addition of amount of energy emitted plus amount of energy reflected. So it is given as J is equal to E plus rho Z. But what is E? E means emissive power. E is equal to epsilon EV. E is equal to epsilon EV. You know what is the formula of emissivity? E upon EV. E upon EV. So E becomes epsilon EV. So we need to get first epsilon EV. How to get that? E is equal to, what is epsilon? Okay, I don't know epsilon. So first I need to calculate epsilon and EV. As you know, surface is a gray surface. For gray surface, Kirchhoff's law is applicable, that is alpha is equal to epsilon. But alpha is given as 0.7, so epsilon has also become 0.7. So I got epsilon. Now I need to get the value of EV. How to get the value of EV? EV is by Stefan Boltzmann constant. EV is equal to sigma T raised to 4. Sigma is what? 5.67 into 10 raised to minus 8. And what is T? That is absolute temperature of the body. It is 470. Just I am going back to the data. 473. 473 raised to 4. So emissive power of a black body is coming as 2837.09 watt per meter square. Okay, that is EV. Now how to get E from EV? E is equal to epsilon EV. So E is equal to epsilon EV. Epsilon value is 0.7 into 2837.09. So the value of E is just now, wait a minute, I will calculate it for you. 0.7 into 2837.09, that becomes 1985.96 watt per meter square. Unit of emissive power is watt per meter square. So I got E. So using this formula, I got the value of E now. So J is equal to, what is the value of E? 1985.96 plus rho Z. What is rho? Rho is, somewhere I have calculated. Rho is 0.3. So 0.3 into G. G is how much? 1000. So the answer of radiosity is coming as 2286.66 watt per meter square. So this is your answer number 3. So students, here completes our first problem of radiation. Now I will go to the second problem. Just I am opening the list. That is problem number 17. starting on a fresh page. Okay, let's interpret the data first. Calculate the rate of heat loss from thermos flask. Now you know thermos flask is made up of two bottles having vacuum filled between two bottles. Means there is a space between two bottles, and in that vacuum means no any air present in between the two bottles. What is given here? Calculate the rate of heat loss from a thermos flask if the polished silver surfaces have emissivities of 0.05. In theory class, I have already explained thermos flask surfaces are made highly reflective. So here there are silver surfaces. Why highly reflective? Because if you are increasing the reflectivity, that is rho, emissivity value of the surface is getting decreased. And emissivity is getting decreased means the ability to radiate the heat is getting decreased. And that's why the surfaces are polished silver surfaces. So let's imagine this is the inner wall and this is the outer wall of the thermos flask, and both walls are having emissivities as 0.05. So let's inner wall I am giving as epsilon 1, that is 0.05, and outer wall I am denoting as 2, that is having emissivity 0.05, because both walls they have mentioned having emissivities of 0.05. Liquid in the flask is 100 degrees Celsius. So this is the inner wall, number 1, and this is the outer wall. So liquid kahan hoga? This side liquid, that is maybe T. Okay, and here what is present? Atmospheric air. Liquid in the flask is at 100 degrees Celsius. 100 degrees Celsius. So liquid ka temperature 100 hai, but the heat transfer coefficient here is not mentioned. So I will consider the liquid temperature and the wall inside temperature is equal to same. So here I will put 100 degrees Celsius. Similarly, outside atmospheric air convective heat transfer coefficient is also not mentioned, and the temperature and the casing is at 20 degrees Celsius. Here okay, directly casing means what? Outside wall, that is at 20 degrees Celsius. And what they have asked? Calculate the heat loss. So see here, calculate the rate of heat loss. Means what is the required answer? They ask to you Q1 to 2, that is the number 1, and number 2 again they have asked calculate the loss of heat if both surfaces are black. Means this is your case 1, and what is case 2? Again calculate heat loss when epsilon 1 is equal to epsilon 2 is equal to 1. Both surfaces are black in the sense what? Inner surface and outer surface both are having emissivity equal to 1 because they are black. So we are having the problem with the two cases. Case 1 where we need to calculate heat transfer rate between two surfaces or two bottles or inner surface and outer surface by considering the given emissivities. And in second case what they mention, now both surfaces, that is inner and outer surfaces, are black surfaces, so emissivity becomes 1, and in that case calculate heat loss again. So we have to solve the problem twice for both the cases. So we'll consider case 1. Case 1 means this case. Okay, case 1. So how to do it? Now radiation heat exchange formula between two flat parallel surfaces is given by Q1 to 2 is equal to sigma A T1 raised to 4 minus T2 raised to 4 divided by 1 by epsilon 1 plus 1 by epsilon 2 minus 1. This is the formula. Now you are saying, sir, thermos flask is made up of two bottles. So it is just a case of two concentric cylinders. So why you have not used the formula of two concentric cylinders? Why I have used for two flat surfaces? You know, thermos flask is having a cylindrical boundary. But here I have assumed that cylinder is broken at one point and then it is sprayed, it is developed. So cylinder, when it is developed, it become a flat surface. So by doing assumption कि thermos flask is made up of two flat surfaces, one is on inner bottle and other is of outer bottle. So two surfaces I have shown in the figure. Now why we have done that assumption, or why bottles we are considering as straight surfaces? There is a reason. They have not given the radii of what is the radii of inner surface and what is the radius of outer surface. They have not mentioned. So we are treating them as a flat surfaces and solving the problem. So now what is known and what is unknown, you find it out. I think everything is known that you can easily calculate. Okay, area is only unknown. If area is not given in the problem, assume area is equal to 1 meter square, as it is not given. Not given. In radiation, you have to assume, if area is not given, assume 1 meter square, and instead of writing the unit of Q as watt, write it as watt per meter square. Okay, let's proceed. Q1 to 2 is equal to sigma 5.67 into 10 raised to minus 8. Area is not given, so 1 T1 raised to 4 minus T2 raised to 4. What is your job? 100 degrees Celsius. You don't require here Celsius because you are solving the problem of radiation. So 100 plus 273, it is 373 Kelvin. Please do it on calculator. Then 20 plus 273, it is how much? 20 plus 273 means 293 Kelvin. 293 Kelvin. And now solve. T1 raised to 4. So what is T1? 373 raised to 4 minus 293 raised to 4. 293 raised to 4 upon 1 upon 0.05 plus 1 upon 0.05. Okay, minus 1. Minus 1. Okay. Now, if I am solving, now see, this expression contains number of terms, and if you are doing it directly on a calculator, there is a problem. You are generally mistaken and you will get a wrong answer. In order to avoid that, my suggestion is do the calculation bracket wise, calculate numerator separately, calculate denominator separately. Now I will calculate only numerator. The value of numerator is coming as 679.65, and I will calculate denominator only, that comes at 39. So the answer of Q1 to 2 is 17.42 watt. So this is answer 1, means for case 1. Now in case 2, we have to solve the problem again. This is 1, inner surface is of thermos flask is 1, outer surface of thermos flask is 2. As the radius are not given, I am assuming them as flat, but now this time they have mentioned assume they are black bodies. So epsilon 1 is 1 and epsilon 2 is also 1. What is T1? T1 is how much? Same case, 373 Kelvin. And T2 is how much? 293 Kelvin, 93 Kelvin, and solve the problem again. What is the formula? Q1 to 2 is equal to sigma A, T1 raised to 4 minus T2 raised to 4 upon 1 upon epsilon 1 plus 1 upon epsilon 2 minus 1. This is the formula used for radiation heat exchange between two flat parallel surfaces. Okay. Now, Q1 to 2 is equal to sigma 5.67 into 10 raised to minus 8 into area not given 1. So T1 raised to 4 is 373 raised to 4 minus 293 raised to 4 divided by 1 by epsilon 1. It is black body now. So 1 by 1 plus again epsilon 2 is also black body minus 1. So 1 plus 1 2, 2 minus 1 is 1. So only numerator is coming into picture. If I am calculating it, it comes around 679.65 watt. So this is a case 2 answer. When both surfaces are assumed to be black, you will find heat transfer rate is 679. But when emissivities are given, it is 17.42. You can see now. Black bodies radiates maximum. So see the value 679 watt. And when the bodies are not black, when the emissivity is less than 1, see, radiation is reduced to a very less value. It is 17.42, black body 679. And if there are emissivities, means they are not black, they are ordinary bodies, see the radiation heat transfer, this is drastically reduced as the bodies are not black. So this problem demonstrates you radiation heat exchange between ordinary bodies where emissivity is less than 1, and radiation heat exchange between two black bodies when emissivity is 1. In that case, we are definitely getting a very high value because black body radiates higher. So this problem demonstrates that also. Now we'll go to the next problem, and that is problem number 18. So I will flip it for you. Let's start interpreting the data. Space between infinite parallel plates means this is the case. Two flat parallel plates are given having emissivity of 0.4, and second one is having emissivity of epsilon 2 as 0.8, and the space between them is evacuated, means there is a vacuum. A polished aluminum sheet with emissivity of 0.06. So this is radiation shield added between two flat surfaces, and this is, I will number it as 3. In theory class I have explained it while deriving the equation. First surface is 1, second surface is, that is last surface is 2, and whatever the radiation shield you are adding, give the number as 3, 4, 5 depending on how many shields are added. Here only one shield is added, so I have numbered it as 3. It has emissivity epsilon 3 is equal to 0.06. What will be the percentage reduction in heat transfer rate due to insertion of radiation shield? So what is the problem? Problem is, what is the required answer? They have asked percentage reduction. But you will not get percentage reduction directly. For that, you require to solve the problem when there is no shield, called as heat transfer rate without shield, and then with shield, heat transfer rate with shield. Let's compare these two, with shield and without shield, then you will get the answer of percentage reduction. So let's go for the solution. Now I will start Q without shield. Means मान लेते हैं कि there is no shield placed between two surfaces. Q without shield. So there are only two surfaces. One is epsilon 1 and other is epsilon 2. So what is the formula? Q1 to 2 is equal to sigma A T1 raised to 4 minus T2 raised to 4 1 by epsilon 1 plus 1 by epsilon 2 minus 1. This is the formula for radiation heat exchange between two flat surfaces, okay, without any shield. Only two surfaces are there and they are having emissivity of epsilon 1 and epsilon 2. This formula we have seen in last problem also. So again we are repeating it. So let's start. Is equal to sigma 5 points. Okay, they have not given the values of T1 and T2 also, so I will keep as it is. I will keep sigma as it is. Area not given, you can assume it as 1, but they have not given the value of sigma also, T1 also, T2 also, so I will put as it is. Sigma A, T1 raised to 4 minus T2 raised to 4, numerator as it is. 1 upon epsilon mean is 0.4 plus 1 upon 0.8 minus 1. So the Q1 to 2 is equal to sigma A T1 raised to 4 minus T2 raised to 4 divided by just 1 minute. I have done the calculation for you. Just 1 minute. it comes around as 2.75. Denominator comes as 2.75. So I will take denominator on numerator. So I will take a inverse of 2.75. It comes as 0.3636 sigma A T1 raised to 4 minus T2 raised to 4. So this is Q without shield. So I got this answer. This is equation 1. Okay, now Q with shield. Q with shield. कैसे होगा? This is 1, this is 2, and only one shield is added, so this is 3. And you know the values of epsilon 1, epsilon 3, and epsilon 2. Epsilon 1, epsilon 3, and epsilon 2. Okay? What is epsilon 1? 0.4. What is epsilon 2? 0.8. And what is epsilon 3? Shield की emissivity कितनी है? 0.06. Okay. Now, what is the formula of Q with shield? Now, when radiation shield is inserted, what is the formula for Q1 to 2 that I am writing? Sigma A T1 raised to 4 minus T2 raised to 4 divided by 1 by epsilon 1 plus 1 by epsilon 2 minus 1. Okay, plus shield की वजह से एक bracket extra introduce हो जाएगा. This formula is exactly same like a previous formula. You see here. Same formula I have written. But because of one shield, there is a one more bracket introduced, and that is 2 by epsilon shield. Shield means I have numbered shield as 3 here. So 2 by epsilon 3 minus 1. ये जो bracket है वो एक shield के कारण है. Okay. So 2 by epsilon 3 minus 1. 3 means one shield. जो कि हमने उसको नंबर दिया है 3. So let's do the calculation. It's simple. So Q with shield is equal to sigma A T1 raised to 4 minus T2 raised to 4. Because they are not given, I am putting as it is. 1 by how much? Epsilon 1 is how much? 0.4 plus 1 by epsilon 2 is what? 0.8 minus 1 plus 2 by epsilon 3. 2 by epsilon 3 is how much? Means shield emissivity 0.06 minus 1. So if I will calculate it, it comes sigma A T1 raised to 4 minus T2 raised to 4 divided by is this bracket has already calculated. Look, this value. That value comes around as 2.75. So 2.75 plus, if I will calculate it, it comes at 32.33. Okay. So I will do the addition of this and I will take the inverse of it. So it will come on numerator. It comes as 0.0285 sigma A T1 raised to 4 minus T2 raised to 4. And this is equation 2. Now I am having Q without shield with me. Now I am having Q with shield with me. How to get percentage reduction? You can see Q without shield is something 0.3636 and sigma A T1 raised to 4 minus T2 raised to 4. And with shield is 0.0285 and this is common. Sigma A T1 raised to 4 and T2 raised to 4 is coming in both equations. So how to calculate percentage reduction? Percentage reduction is Q with shield minus Q without shield. ये reduction हुआ. But now we have to calculate percentage, na? So again divided by Q without shield into percentage के लिए into 100. So let's do it. Percentage reduction in heat transfer by adding the shield is equal to, what is the value of Q with shield? With shield is coming as 0.0285, 0.0285 minus what is without shield? 0.3636, 0.3636 divided by without shield is 0.3636 into 100. Now you are saying, sir, why you have not taken sigma A T1 raised to 4 minus T2 raised to 4? Because it is coming attached to every value. So at the end it is taken common from numerator and it is cancelled with denominator. So need not to take it. Okay. You can try it. Later on you will understand that is get cancelled from numerator and denominator as they are same. So if I will calculate it, the answer comes as minus 92.16%. Why minus? Because negative sign indicates that there is a reduction in heat transfer. There is a reduction in heat transfer by adding one shield, radiation shield. So it is proved. Answer comes negative means what? There is no enhancement, there is no increase in heat transfer rate. शील्ड डालने के बाद हीट ट्रांसफर रेट रेडिएशन से कमी हो जाता है, रिड्यूस हो जाता है, and that's why the minus sign automatically appears. So remember, this is the formula for calculation of percentage reduction in heat transfer rate. Okay. Now we'll go to the next problem. I will come back to the list of the formulae and I am snipping it further. Now I am going for problem number 19. Okay. So I am writing the data from the problem. Two large parallel plate. So these are the two large parallel plates P and S, name given as P and S, are maintained at temperature of 1227 degrees Celsius. 1227 degrees Celsius. Better to convert directly in Kelvin. Okay, I have done it for you. It is 1500 Kelvin. 1500 Kelvin. And then 327 degrees Celsius, convert it in Kelvin, it comes as 600 Kelvin. Because in radiation we require Kelvin values, Celsius are not allowed. Their emissivities are 0.9 and 0.4. Means P को मैं 1 मानता हूँ. Okay, just 1 minute. P को मैं नंबर देता हूँ 1. यस को मैं नंबर देता हूं, हमारी यूजुअल प्रैक्टिस, पहला जो है 1, दूसरा जो है 2. ओके, 1 and 2. So epsilon 1 is having 0.9 and other is having epsilon 2. means जो यस नंबर है, यस की प्लेट है, यस means 2, epsilon 2 is how much? 0.4. Two radiation shields Q with emissivity 0.5 and R with emissivity 0.2 are inserted in between them such that PQ RS are placed in one another. क्या किया है उन्होंने? Q और R ये दो रेडिएशन शील्ड, इन दोनों के बीच में, P और S के बीच में दो शील्ड डाले हैं. तो एक है Q और एक है R, so that PQ RS are placed one after another. देखो P, Q, R and S, they are one after another. And emissivities are given for them also. Q को नंबर देता हूं मैं. You know, I told first is 1, last is 2, and if the radiation shields are added, number them as 3 and 4, 5, 6 like that. Here two shields are there, so 3 and 4. So 3 and 4 are Q and R only. So what is the emissivity of Q? Q with emissivity of 0.5. So epsilon 3 is 0.5 and R with emissivity of 0.2, R को क्या बोला है हमने 4, so epsilon 4 is how much? 0.2. Okay. Now what they have asked, calculate temperature attained by plane B and C. So what is the required answer? Required answer is TB and TC, number 1 and number 2. Okay, now the solution. It is a case of two flat parallel surfaces and with shield. Okay, no matter, instead of one shield there are two shields. So what is the formula? Better to write it, as it is a bigger, I will write on a new page. Q1 to 2, that is first to last. What is first? P. And what is last? S. So from first to last, what is the radiation heat transfer if two shields are inserted? So let's write the formula. Sigma A T1 raised to 4 minus T2 raised to 4, okay, divided by a long line you need to sketch because a number of things are coming at the bottom denominator. 1 upon epsilon 1 plus 1 upon epsilon 2 minus 1. This formula belongs to what? It is radiation heat exchange between two flat surfaces when no shade is there. Nothing is there in between. This is the formula. But there are how many shades now? Two shades. So two brackets are extra coming on denominator. 2 by epsilon, पहली शेड है epsilon 3 minus 1. ये पहले शेड का ब्रैकेट है, that is number 3. And और एक शेड है, so 2 by epsilon 4 minus 1. So this is the formula. Okay. So let's put the values. Let's put the values. Now sigma 5.67 into 10 raised to minus 8. Area is not mentioned, so 1. T1 how much it is? T1 Kelvin, 1500 Kelvin, 1500 raised to 4 minus T2 327 degree Celsius, 600 Kelvin, 600 raised to 4. Celsius avoid karo, only Kelvin. In bracket 1 by epsilon 1, 1 by 0.9, 1 by epsilon 2 कितना है? Epsilon 2 is last. Last means yes split 0.4 minus 1 plus 2 by पहली शील्ड जो डाली है that is Q. ये Q जो है पहली शील्ड नंबर 3 0.5 minus 1 and last शील्ड का ब्रैकेट that is शील्ड नंबर 4, it is R. Epsilon 4 is 0.2, so 2 upon 0.2 minus 1. Okay, if I am solving it, I will get numerator as, I will solve numerator as separately, so I will get 279695.43. Only numerator I have solved. Now I will solve each bracket separately and I will write it as 2.6111 पहला bracket, this bracket, then second bracket का answer it comes as 3 and third bracket का answer it comes as 9. So if I will calculate it, the final answer comes as 19,142.66 watt per meter square. Why per meter square? The reason is area I have assumed as 1. Okay, अगर area की value होती तो it becomes only watt, but area I have assumed as 1, so it is watt per meter square. So I got the answer. But this is not asked to you. Sorry, this is not the answer. What they have asked to you? They have asked temperature of, sorry, not B. This is wrong. Temperature of not B and C. They have asked temperature of shields. So Q and R. This is Q and R. Please make the change in the problem. It is not B and C. It is Q and R. So it is T of Q and T of R. They have asked T of Q and T of R. So how to get that? Now this is P, this is Q, this is R, this is S. I have numbered it as 1, 2, shield as 3 and 4. This is P, Q, R and S. P का temperature आपको पता है, how much it is? 1500. यस का टेम्परेचर भी आपको पता है 600 केल्विन, and they have asked for Q and R. But you know that we have obtained the answer of Q1 to 2, that is first to last. What is the answer? Q1 to 2. Under steady state, Q1 to 2 is Q1 to 3, Q3 to 4, and Q4 to 2. This is true for steady state. So by making use of this expression, we are able to calculate the temperature of shields. How to do it? Let's take 1 to 3. I will consider 1 to 3. Why I am considering 1 to 3? There is a reason. I know 1 means T1. T1 I know na 1500. But I don't know T3. T3 means what? TQ. So I can use this. And what is the answer of all? This I know already. The answer of all is what? 19142.66 watt per meter square. So this I know. So Q1 to 3, I will generate the formula between the plate 1 and 3. How to write the formula? Just like we have written for 1 and 2, write it for 1 and 3. Okay, so 2 is replaced by 3 now, and write it. Sigma A T1 raised to 4 minus T3 raised to 4, as if you are writing between 1 and 3 rather than 1 and 2. So 1 by epsilon 1 plus 1 by epsilon 3 minus 1. Okay, now just put the values. Q1 to 3 is already known. Under steady state it is same na. So 19142.66, that I know. Sigma is 5.67 into 10 raised to minus 8. Area not given means 1. T1 raised to 4. T1 is 1500 raised to 4 minus TQ. TQ means T3. T3 is unknown. T3 raised to 4 divided by 1 by epsilon 1. 1 by epsilon 1. What is the value of epsilon 1? 0.9 plus 1 by epsilon 3. What is epsilon 3? 0.5 minus 1. Okay. If you solve this step by step, I will do it like this. I will calculate this bracket separately. Then this bracket I will multiply with this left hand side term. Then 5.67 into 10 raised to minus 8 I will take on left hand side, so it goes on denominator, and then I will calculate T3. So the answer of T3. Now here it's very important. You will get the answer of T3 raised to 4 first. So you have to take 4th root of T3 raised to 4. So automatically you will get the answer of T3. So T3 is equal to 1444.16 Kelvin. Students, do it on calculator. I have done it already for you. That's why I have written directly. But you have to do it on calculator because you need to know how to do raised to 4, how to take a 4th root of any value. So that is very, very important. So if you are not doing it on calculator, then it's very difficult. Otherwise, what will happen? Everything is correct for you. Procedure, formula, everything is correct. But you are not able to do the calculation properly with the help of calculator. Means you don't know how to use the calculator. Then you will be in trouble. So better to practice it on calculator so that you will understand how to do the calculations for radiation. Radiation involves formulas which is lengthy. They are consisting raised to power 4. Then you need to take 1 by 0.9, 1 by 0.5 means you need to take inverse also. Okay, reciprocal also. Reciprocal means inverse. Okay, so practice on calculator is must. So this is your answer T3, and that is your what? TQ. Okay, so you got answer number 1. Okay, now next. Now you can apply it between 3 to 4, and you can apply between 4 and 2. By any way you can do, because one should be known out of 2. 4 और 2 पेयर अगर आप लेंगे तो 2 का टेम्परेचर आपको पता है 600 केल्विन. 3 and 4 अगर आप लेंगे तो आपको T3 अभी अभी पता चला है और T4 अननोन है. So by both the ways, either on left hand side or right hand side, you can go. I will take 4 to 2 combination. Okay. So Q4 to 2, write the formula as if there are only two surfaces. First surface is numbered as 4 and second surface means this is like this. This is numbered as 4 and this is numbered as 2. What is the formula? Replace it. You have written already for 1 to 2. Now you are writing for 4 to 2. So how to do it? Sigma A T4 raised to 4 minus T2 raised to 4 divided by 1 by epsilon 4 plus 1 by epsilon 2 minus 1. So if you are doing it, Q4 to 2 is already known. Under steady state it is same, 19,142.66 is equal to sigma is 5.67 into 10 raised to minus 8. Area is 1. T4 is unknown. That is only TR raised to 4 and T2 is known to you. What is T2? T2 means this one. Plate S. What is the temperature? 600 Kelvin. So that I know. 600 raised to 4 divided by, sorry, this is not here. It has to be here. Divided by 1 by epsilon 4. What is epsilon 4? 4 means R. 4 means R. It is epsilon 4 is 0.2. 0.2 plus 1 by epsilon 2. What is epsilon 2? Epsilon 2. This is 2. So epsilon 2 is 0.4 minus 1. And if I will solve it, पहले ये ब्रैकेट कैलकुलेट करो, इस ब्रैकेट को इससे मल्टीप्लाई करो, देन 5.67 इंटू 10 रेज़ टू माइनस 8 से डिवाइड करो क्योंकि वो लेफ्ट को आएगा तो डिवीजन डिनोमिनेटर पे जाएगा एंड देन यू विल गेट द आंसर ऑफ T4 इज इक्वल टू 1234.70 Kelvin. No, not necessary to convert in Celsius. Keep as it is. Okay, and T4 is what? TR is it. This is your answer number 2. Okay, so this is the way to calculate intermediate shield temperatures or intermediate plate temperatures. So can we move to the next problem? Okay. Problem number 20. Okay, let's interpret the data from the problem. Two large parallel plane with emissivity means I need to draw the two large parallel planes with emissivity epsilon 1 as 0.8, epsilon 2 as 0.4. Okay, 0.8 and 0.4 have temperature 427 degrees Celsius means how much? 700 Kelvin. Adds 273 in it, and this is 27 degrees Celsius, so add 273, so it becomes 300 Kelvin. Convert in Kelvin immediately. If they are kept facing to each other, find the rate of heat transfer between them. Okay, so nothing is added in between that as a shield. Only two surfaces are there and they have asked you calculate heat transfer between them means Q1 to 2. But there is a next case. If this rate of heat transfer is reduced by 1/4 of its original value means अभी सिर्फ 2 है, 2 में कोई शील्ड ऐड नहीं है, तो आपने हीट ट्रांसफर रेट कैलकुलेट किया. अभी आप वो क्या बोल रहे हैं कि हीट ट्रांसफर रेट इज रिड्यूस टू 1/4 ऑफ इट्स ओरिजिनल वैल्यू. अभी हीट ट्रांसफर रेट रिड्यूस कैसे होगा? ओनली बाय एडिशन ऑफ शील्ड. ओके, सो उन्होंने बोला है कि पहले अगर कुछ अमाउंट आता है हीट ट्रांसफर रेट, उसको 1/4 से मल्टीप्लाई करो, मींस उसका 1/4 वैल्यू निकालो, दैट इज योर न्यू हीट ट्रांसफर रेट बाय एडिंग अ शील्ड. ऑफ कोर्स हीट ट्रांसफर रेट कम क्यों होगा? 1/4 कब हो सकता है? शील्ड ऐड करने के बाद ही हो सकता है ना. तो आगे देखेंगे कैलकुलेट द इमिसिविटी ऑफ द रेडिएशन शील्ड इंसर्टेड बिटवीन देम। देखो मैंने बोला था आपको अगर वो 1/4 रिड्यूस हो चुका है तो नेचुरली शील्ड ऐड किया है, इसी के कारण हुआ है। सो व्हाट दे आस्क्ड यू, शील्ड तो ऐड की है तो उस शील्ड की आप इमिसिविटी निकालो। ओके, बट दे हैव मेंशन समथिंग हियर, कैलकुलेट शील्ड हैज सेम इमिसिविटी ऑन बोथ साइड्स। मींस फॉर एग्जांपल दिस इज अ शील्ड, तो शील्ड के लेफ्ट साइड एंड राइट साइड on both surfaces emissivity is same, that is assumption. So with that assumption only we have derived our equations, and if the shield has different emissivity on both surfaces, then what to do, that I have already explained in the class. Okay, if such problem is there I will explain further. Okay, but here in this case emissivity is same on both sides. Okay, so we'll solve case 1. What is case 1? Without shield, calculate Q1 to 2. And what is case 2? Required answers. What is case 2? One shield is inserted. One shield is inserted, and in this case you need to calculate epsilon of that shield. Yes, epsilon, yes. Okay, but in that case your new value of Q, I will case 1 I will put it as Q1. New value is treated as Q2, that is 1/4 of original value means Q1. शील्ड डालने के बाद हीट ट्रांसफर रेट कितना हुआ, 1/4 हुआ, सो Q2 इज 1/4 ऑफ Q1। एंड अगर ऐसा होता है तो किसके कारण हुआ, वो शील्ड के कारण हुआ, तो उस शील्ड की इमिसिविटी निकालने को आपको बोला है। सो एप्सिलॉन यस आपको निकालना है। नाउ विल गो फॉर द सॉल्यूशन। सो दिस इज सिंपल, when there is no shield, Q1 is equal to sigma A T1 raised to 4 minus T2 raised to 4. What is the formula between two flat parallel surfaces? 1 by epsilon 1 plus 1 by epsilon 2 minus 1. तो सीधा सब्स्टिट्यूट करो। Q1 means without shield, sigma 5.67 into 10 raised to minus 8. Area is not given, so 1. T1 raised to 4. What is T1? 700 raised to 4 minus T2 is 300 raised to 4 divided by 1 by epsilon 1 is how much, 0.8 plus 1 by epsilon 2 is 0.4 minus 1. If I will get the answer of this, Q1 is equal to, Q1 means it is actually Q1 to 2, but इसको Q1 क्यों बोला है, without shield. So Q1 is equal to, it comes as, if I will do the calculation of numerator separately, it comes at 13154.4 and denominator this bracket. If I will calculate separately, it comes as 2.75. So if I will do the calculation, the answer comes as 4783.41 watt per meter square. Why per meter square? Because the area is assumed as 1. Okay, so this is without shield. So this is your answer number 1. Okay, case 1, no shield is there. Now there is one shield inserted, but what is the new heat transfer rate? Q2 is 1/4 of Q1. So 1/4 is into 4783.41. शील्ड डालने के बाद हीट ट्रांसफर रेट 1/4 से कम हो गया, तो मल्टीप्लाई करेंगे आप यहाँ, तो आंसर कम्स एज 1195.85 watt per meter square. What is the formula of without shield? Q2, sorry, with shield. Let's take a case. This is 1, this is 2, and shield को आप क्या कहते हो, 3 कहते हो, 3 या यस लिखो उसको कुछ भी, लेकिन हम वही नोटेशन देंगे जो हमने डिसाइड किए हैं। 1 is the first, 2 is the last, and 3, 4, 5, 6 जितने शील्ड आप ऐड करोगे वैसे नंबरिंग करेंगे। सो शील्ड का नंबर मैंने 3 दिया। ओके, तो यहां भी मैं यस के जगह क्या लिखता हूं, शील्ड मींस पहली एक ही शील्ड डाली है तो एप्सिलॉन 3, जो कि आपको अननोन है वही तो निकालना है। ओके, दिस इज द केस। सो इन दिस केस व्हाट इज द फॉर्मूला, सिग्मा ए T1 रेज़ टू 4 माइनस T2 रेज़ टू 4। पहले विदाउट शील्ड का फॉर्मूला लिखो, क्या है, 1 by epsilon 1 plus 1 by epsilon 2 minus 1. और एक फॉर्मूला, एक ब्रैकेट ऐड हो गया डिनोमिनेटर पे, क्यों? क्योंकि एक शील्ड है और उसका फॉर्मूला क्या है? 2 बाय एप्सिलॉन शील्ड। शील्ड क्या है? 3 माइनस 1। ये शील्ड की वजह से ये ब्रैकेट आया। एक ही है, दूसरा शील्ड होता तो और एक ब्रैकेट आता ऐसे ही, और उसको आप एप्सिलॉन 4 लिखते बस। ठीक है, now I will go for the calculation. 5.67 into 10 raised to minus 8, that is sigma. Area not given 1. T1 700 raised to 4 minus 300 raised to 4 divided by 1 by epsilon 1, 1 by 0.8 plus 1 by 0.4 minus 1 plus 2 by epsilon 3. कितना है epsilon 3? That is unknown. That is unknown. वही तो कैलकुलेट करने को पूछा है, -1 is equal to, but Q2 is how much? Q2 is how much? That is equal to 1195.85, जो कि reduce हो चुका है 1/4 से. So that already I know. Now you have to solve this equation to get the answer of this epsilon 3. So let's start with numerator. I think ये numerator पहले जैसा ही है और वो ऑलरेडी आपने कैलकुलेट कर चुके हैं आप यहाँ न्यूमरेटर. देखो सेपरेट कैलकुलेशन का फायदा क्या होता है, तो वापस कैलकुलेट करने की जरूरत नहीं पड़ी ना. डायरेक्टली आई विल पुट नाउ Q2 is equal to 13154.4 upon denominator. This bracket is already known to you. This bracket is already known to you, that is 2.75. ये वाला bracket. Look at this. This is already known, that is denominator in case 1. 2.75. ये 2.75 वो ये ब्रैकेट है. सो 2.75. तो देखो आप सेपरेट कैलकुलेट करने का फायदा क्या है, कभी कभी आप कैलकुलेशन वापस करने से बच जाते हो एंड योर टाइम इज सेव्ड. प्लस 2 बाय एप्सिलॉन 3 माइनस 1 एंड Q2 की वैल्यू कितनी है? 1/4 ऑफ Q1, दैट आई नो इट, 1195.85. 1195.85. नाउ let's do the cross multiplication. Okay, so अगर मैं ये 1195.85 इस तरफ लाता हूं और ये राइट को जाता हूं तो ये क्या होगा? 13154.4 अपॉन 1195.85 इज इक्वल टू 2.75 प्लस 2 बाय एप्सिलॉन 3 माइनस 1. एंड इसको अगर आप सॉल्व करेंगे तो आंसर बिकम्स एप्सिलॉन 3 इज इक्वल टू 0.2162. So this is your solve step by step and you will get the answer on the calculator as this is answer 2. Means after adding the radiation shield, heat transfer rate is reduced to 1/4 value of original, but at that time emissivity of the shield is not given, that we have calculated as epsilon 3 is equal to 0.2162. So that's it in this lecture. Remaining radiation problems we will see in the next lecture. Thank you.